Hello, good evening, everyone. Welcome back to the Starknet Developer Basecamp. I trust you had a restful weekend, and this is a session that we've really been looking forward to, all of us, because in this session we are going to learn and to understand how decentralized application works, how a blockchain application works, because we are writing our smart contract deploying and seeing how our front end is going to interact with our backend, which our backend will majorly be the smart contract. Yeah, so feel most welcome to join our session today. My name is Harriet, and Dalmas will take us through the sessions, and even Christopher and myself will be here on board. Um, we had indicated that we'll be having different method of submitting our assignment for those who are not in the WhatsApp group, because the previous way of that we suggested, we had the learners not really submitting the assignment properly, so we've decided to change. So you do your assignment and share with us your GitHub repo. I'll share with you the email, hello@beachinafrica.com. That is the email to where you send your GitHub repo. Also ensure that the visibility of your GitHub repo is public so that we will manage to see your work, assess, and give you feedback. So for all other communications, you are free to drop a message there on the comment section if you want to ask a question by joining our studio so that we can hear what you're saying. You can also make that request so that we share with you how to join our studio. Thank you so much for showing up. I'll hand over the session to Dalmas. Over to you, Dalmas. Thank you.
Thank you, Harriet. I hope you are all doing well. So today said we are going to cover something critical. As much we have been covering lots and lots of things critical. So we started off by simply introducing ourselves to Starknet. Then we covered a bit about Starknet, how Starknet works. We went ahead to learn Cairo. We went ahead to do a simple smart contract, did an interaction with it. So today we are taking that one further, where we are going to explore on how to interact or integrate our smart contracts to a front end, and also how to now write different things, achieve different capabilities on Starknet. That includes things like smart contracts, writing your own ERC20, ERC721, and all those. So without much ado, I'll share my screen and we'll get started. I believe it is visible. I think I'll give it some time. It comes up right. It should now be visible. I believe so. Okay, nice. So I'll sort of immediately present so that we can get started. So I'll have to go back to where we start off with. So today, the topic of the day is front-end integration. That's on Starknet, of course. So this session 5, I believe you have been following through to session 4. And today is one of, let's say, the last session for those who are just going to do the apps. But for those who like gaming, then there will be another extra session, session 6, where we'll be covering Dojo, introduction to Dojo literally. So we'll also be able to see how to build games on Starknet. So we did go through setting up a development environment. If you hadn't gone through or you missed this one, kindly check session 2 to this program. You'll be able to find the entire setup process. Then Here I've just gone through like a quick guide. So installing Rust, DevNet, Foundry, Scab, then setting up VS Code and all those things. So I'll just scroll up a bit. So we have the basics of Kira and smart contracts. We did cover this one in the last session, that's session 4. And we did say uh, there are functions, state variables, and events. We didn't like fully cover events, but today we'll just introduce events too, so that you'll be able to see how they work also. Functions, you know how they work. Uh, state variables are stored in the storage struct. We did talk about a bit about that one. Then we have the events here. So I said events is what we didn't like cover. So I'll have to add it today in our list. So this will be our starting point. And let me just present my other screen, or let me present the VS Code so that we can be able to see what goes under that one. So we had our Hello Starknet contract. So I'm going to open it. We have it up and running. Just a moment, checking something on my notes here. Yeah, so this is our contract that we had before. And in our contract, we said you can sort of increase balance and get the balance. So let's look at the events and how to use events. So we are going to have 2 events here. Okay, one event that will be emitted once we increase our balance. Every time we increase balance, then we emit that specific event. That's what I did not covered from the previous sessions. That's more so session 4. So events like storage, there's always one single event struct in in Starknet smart contracts. In your contract, always there will be only a single event struct, the same as there is a single storage struct. So I'm going to just write it. And also when writing it, you have to write it like that, struct event. So you have to do it like that. Then you have to sort of decorate it with the hash event attribute. That way it will be able to say, okay, let's have this one here. After doing this, you need to now write the rest of the events that you want to have here. But before that, you need to also add a few attributes that includes derive. So we are going to derive here the drop, and also we are going to derive Starknet event like that.
Excuse me, Dalmas, your font is too small.
Okay, thanks for highlighting that. I think I left. Don't know whether that one is visible. Yeah, yeah. Is that one visible?
Still tiny, try zooming in.
Okay, let me see. Okay. Plus there.
Yeah, that should be fine.
Okay. Yeah. So once we have this set up, now it's time to write the event. So I've said you just have to decorate it with the hash event, then hash derive. You derive the drop and the Starknet event attributes. Then after that, you're going to write your specific events. For for those specific events, you have to also write them within this module. You cannot write these structs outside the module, otherwise they are going to fail. So all the event structs, they have to be within the contract module. So that is, so I'm going to have the event called increase balance. So it's just struct increase balance. It's going to be decorated with the hash Starknet. We need to derive this one. Derive into brackets Starknet event like that. And also we derive drop like that. And in our increase balance, we are going to have the field that we want to increase the balance with. For this case, it can be something like maybe the new balance or new something like a new balance. And these are felt. Are we using felts? Yeah, we are using felt 252s. Felt 252 like that. Then after doing this, you need to now register your struct or your now event into the event struct. You do increase balance, then so this will be the key and this will be the value of it. That's how you write events. So we are increasing with the amount. So let's just use amount here instead of new balance. Let's just have amount like that. So that's an event. But for you to index these various keys that will be in this specific event, you need to attribute this one using hash key like this. So this will sort of index this specific key, amount key. So once we have this one set up, the next portion is now to emit a given event. To emit an event is just simply using self.emit. So we'll be using the emit function. And what we are going to emit here is called increase balance. Increase balance event. Then it's going to take in amount with the amount that we are going to emit it with. So that's how it goes around this, but I'm having some error here. I think I'll just zoom out a bit and I try to identify the problem of where the error is coming from. So I'm getting here it's saying SADE, something to do with SADE. So I believe let's try to add SADE here and see whether it will solve. Not yet. Yes. Yeah, I think I know why it's not working. The problem is not really SADE, but the way I have written these values or the way I have written out this. The event is not a struct or the event, whatever called the struct here. This should be an enum. That's the problem. Sorry for that. So you can only have like this single enum that will be able to track.
Uh, so let's just keep locked. I think the presenter has dropped out a little network hiccup, but he'll just be back. I hope you can hear me, Samuel Mwendwa. So our presenter is just coming back. Probably you can just hold on there. He was discussing on the presentation or on the writing of events. Yeah, like the event was not part of a struct. So let's just hang on there. He's coming back. Oh, thank you. We can also just start dropping our questions, even from the previous classes. What has not been clear, we can drop them in the comment section. Yes, our presenter is right back.
Sorry for that. Got some network interruption, but I think I'm back.
It's fine. It's fine. You can carry on.
Okay. So yeah, we were talking about events here, and I decided I'd made some slight mistake here calling this the main event as abstract, but it should be an enum. So remember that. So this should be an enum event, and it can only be one enum of this kind. Then it has to be decorated with the hash event uh, attribute. After that, you do your different values there. So increase balance, and you map it to increase balance abstract. So at least call your events whatever you have for structs. That will be better. So this can be increase balance event or something. So I think let's call them event complete like that, and it will look good. So I'll just do like that so that we can separate between events and the normal structs. Once you have done that, you are good to go. The next portion, of course, is now to build and deploy your contract. There's no easier way to directly test out these events on DevNet, but now we are going to proceed to the next step. That includes deploying this or writing a front end that will handle our event or that will handle our simple contract. It's the same contract we are going to use. And for a quick recap, this is a simple smart contract that has two functions. The first function is increase balance, and another function is to get balance. Increase balance is a write function or a write method, and the get balance is just a read-only function. And we said our contract is called Hello Starknet because this is what we have decorated with your Starknet contract. So Hello Starknet will be our contract. Then after that, we have our storage here, and the storage struct is only storing the current balance. By default, we'll start at 0, but the moment we call the increase balance method, the balance will be increased by a given amount. Then after the increasing the balance, we have also added the event emission. That is so now we are emitting this specific event here called increase balance event. And we have said to set up events, just have your main enum event within your contract or within your module, your contract module. That's where you have to write everything to do with events. So if you try to move this one out there, for example, there, things might go south. So keep them within the contract. After that, we have the get balance method, and we have said the get balance method is just a read-only method that returns the current value in our contract. So for another thing to recap about the CLI stuff, scab to build your contract, use the command scab build. So all these tools, the environment setup was set up in session 2. That's in the deep dive into Starknet. That's where we did set up our environment. So we talked about Scab, Starknet Foundry, Starknet DevNet to be specific. And now today we are going to add Sepolia to the list and mainnet to the list. So that's how you build your contract, Scab build. Then to deploy your contract, we had covered using Starknet SNcast, and that's what we did. We did write or introduce a symbol account here or create a symbol account, and this one was done in session 4. So if you follow the previous session to this, you can be able to see how we did this, but I'll just go through to have a quick recap over the same before we go to the front end so that we can link all things together and we see what we have. So here I'm going to try to deploy our contract. So this is our simple contract we have here called Hello Starknet. Yeah, I think that one is visible. First, I'm going to run Starknet DevNet. So I'm going to open the my other terminal here and type in Starknet DevNet. So this is going to run DevNet. And we said Starknet DevNet is a local development environment like Travel that will help you quickly iterate over your contract, do the tests that you want to do before you even hit Sepolia or before you even go to mainnet. Goili has been deprecated, so don't bother looking for Goili faucets anywhere, if believe it's the Ethereum or Starknet or another chain. So just focus on Sepolia for testnet or for test environment. And Starknet DevNet, whenever you run it, there are a few flags you can pass with it, but by default, if you just run Starknet DevNet, it will just pick a sequence that it will use to generate the different keys, and also it will generate 10 accounts for you that are uh, pre-filled with some amount of stack ETH and some value there. Then this the sequence to generate this, or seed phrase sequence to generate this given accounts. Yeah, that's a simple walkthrough on Starknet DevNet. Going back to deploying our contract, we said to deploy to Starknet DevNet, first we'll need to have an account. And by default, we had created this account here called account one. But today we are just going to create another one. We are going to call this account deploy account. And I said we will be using a sendcast to do this. So a sendcast account add dash dash help. That's the command. We are going to add an account to, or create link an account that we are going to use to declare deploy and interact with our contract. So we are going to use the sncast account add command to do that. So I'm running the help command here to see the different values that I need to pass in order to add this specific account. So sncast account add, we need to pass in the name, the address, the type of the account. For this case, we are going to just use Open Zeppelin. But what if you were just using like an account from the wallet? So that is for the case of Sepolia or for the case of mainnet. If that could have been the case, you need to do the same, but just now change this one. If you are using an agent account or a Bravos account, then pass in the rest of the information. That includes private key and the public key. So let's quickly do that. So clear this one, sncast. First, we are going to pass in the URL, and the URL in this case is going to be http://localhost port 5050/RPC. So URL in this case is like the RPC endpoint that you need, or SNCast will be using. Then the next command is account. The other sub command is add. Then from there, we need to pass in the name of the account, and this is going to be called deployer. And after the name, we are going to pass in the address of the account. And the address of the account, we are going to copy one from our accounts here, and account address we have been given here. So I'm going to copy that one, paste. Then I'm going to pass in the private key. So when it comes to deploying to Sepolia or to mainnet, the suggestion is don't just copy and paste things like this. Usually you save them in an environment variable so that you don't expose them. But since we are on just DevNet, you can do whatever you want. So I'm going to pass my private key here. And then finally public key, public dash key. I also paste one. And also I'm going to pass in, just a moment, I close this one. The type, I believe it's type, and is Aussie or Open Zeppelin. Then I'm going to add another flag here called add profile, and the profile I want to add is deployer. That's the profile we are creating now. So if you do that one, then you'll notice it will give you a prompt saying profile deployer successfully added to snfoundry.toml. So if I go to my snfoundry.toml, I'll be able to find the newly created account. So those who have a background in it, they can be able to see through this, the Open Zeppelin stuff. So that's an account that we have created. So we are going to use this account to do what we want to do. For example, declare our contract, deploy it, and interact with it. So I'm going to delete this default account given here, just like that, and then make this one the default account by changing this one to sncast.default. So it will be using deployer as the default account. So you don't need to just pass in your private key or your public key and your public key in order to do or make a call. Before, if you were using tools like Starkly, that's Starknet CLI itself, we could just pass in the private and public key or even the account file itself. But SNCast makes all this easy. So we did build our contract using the scat build command. Usually when you have updated your contract, you just need to clean your environment before building again. So I'm going to use the command scab clean, and after that scab build, so that we have a fresh build of it. We have that one built. The next command is to deploy our contract, or the next step. And in deployment, we start by declaring, then to deploying. So Starknet declare dash help, yani sendcast declare. So in declaring, you need to pass in the contract name, and that's it in most cases. So sendcast declare, the contract name will be hello Starknet. So it's going to declare this one, and it has given back a transaction hash and also a class hash. So we need to take care of the class hash. So just copy that one and save it somewhere. The next command is sendcast deploy dash help. And in deployment, we have some variables or some things that we need to pass in. That includes the class hash, the constructor called data, and some others. So these two are the most common ones. If you have a constructor in your contract, then you need to pass in the constructor called data. Otherwise, we only need to pass in the class hash. So I'm going to call that one. So -g and paste my class hash in, then call. So it will return me a contract address that I also need to keep secure somewhere. So I'm going to copy that one and pasting it here. I'll comment it out. So that's our contract. Then we can now call or interact with our contract. So sncast call. So call is to read from the contract. If you do recall, I had said get balance is a read-only method, while write balance is a write method. So sncast call is now to call the read-only methods. So I'll just do sncast call, and it will require a contract address. So I'll pass in the contract address, and after that the function, which is get balance. And if there's any other call data, we could have done it like that, -c 1 2 3, but we don't have any call data, so it will just remain like that. Then hit enter. So you realize the response is 0x0. Then if we try to write to the contract, so sncast invoke, that's the method invoke, or the command rather. Then the method is called increase balance, so increase balance. And increase balance has some call data values or has some parameters that you need in. So I'm going to pass in -c or constructor call data to 2. So if I do that, I get a transaction back, a transaction hash. That's what usually happens when you're writing. When you're writing to a smart contract, you don't return custom objects. You will only be receiving back a transaction hash. Then you can go ahead and wait for the transaction, then read the receipt to read the events and all other things. And here I'm going to call again the method, and you realize our response now is 0x2, meaning our balance has been increased by 2. But we can't tell whether our event was emitted. So we'll test that one the moment we hit uh, our front end. So that's the next portion of this. So integrating the contract to the front end. We have already our contract here set. Now it's integrating it to the front end. Don't know whether there are any questions so far before we get started on the front end portion of things. Now, okay. So if there are any questions, drop them. So let's build a front end for our application. And for our front end, we are going to use a tool that we that's provided by Starknet. That's called Starknet JES. That's the Starknet JS SDK. It's going to help us interact with our contract from our dApp now, from the user-facing application. So here we have getting started and all those installation setups that you'll need. First, npm install. That is if you are using npm or yarn add Starknet. Then with DevNet, you'll have to sort of there are other procedures that you'll need to follow through here. Otherwise, I'm going to go through everything, but I'll show you how to integrate it to your front end. So let's get into it. So I'm going to create a new project. For this case, I'm just going to close this one down for a moment like that. Then for our front end, it will just be a simple front end. So using Vite, I'll just open the Vite, uh, getting started with Vite. I'll be using Vite in this case, or React. If you are familiar with create React app, create React app will also do the same thing. But in this case, I'm just going to use Vite. I believe Vite is more easy and direct to use. So I'll just copy this command, yarn create Vite app. Okay, I did use a wrong value there. And here I'm going to create a new folder. I'll call this one frontends. And here I'm going to create an open in terminal and paste my command there. So yarn create Vite, and it won't my view app, but rather hello Starknet frontend, like that. So it's going to install the create Vite command tool, then it will initialize a new Vite project. So Vite,
Dalmas, your font
yes,
again is your font again is now so
okay, sorry for that. There we go. So here is the command yarn create Vite uh, and the project name hello Starknet frontend. Not sure why it's delaying there. So usually when you don't have these tools set up in your machine, it will take a few more minutes, few more seconds to get set them up before it does what you want it to do. So it's going to ask us how do we want to do it. So select framework. It has gone with the vanilla. I don't think if I'm going to go with vanilla. So I'll just go with I'll just exit this one. Vanilla is never the easier option when dealing with such things. So I'll just go with the yarn create React app hello Starknet frontend. Don't think if I have this create React app command set up. Nope. So let's okay create Vite. For more details we have React. Okay, where's React here? Oh, here we have React. I need to pass in the template. Okay, that's fine. Can do that. Yarn create Vite hello Starknet dash dash template React. So it has done that one. ls, so I can cd into the hello Starknet frontend and open it in VS Code. I think my VS Code is visible. So in VS Code we have the basic React setup, but let's just run this and see what we have. First, since we are here, we are going to just install the dependencies. If you are using npm, just type in npm install or npm I, but for yarn, you just type in yarn and it will install the dependencies from the package JSON. Usually when you draft applications from these tools. For example, the Vite tool, it will just give you an application that has no node modules, so you have to install the node modules before you proceed. We have everything here in the package. Currently, it has React and React DOM, so you have to let it install the dependencies first before you can proceed to running your application. So a few more seconds. So, okay, while it's finishing up, we can continue exploring the what we have here. We have the a few folders, so that's public and SRC folder. Then we have other files here. So this is a common Node.js project setup, which has package.json. For Vite, you have index.html here. So this way you can just change a few things like the title, though this is not how you will entirely do it at the end of the day. Then we have .git ignore that just ignores a bunch of files and folders. Yes, lint for linting, and also we have now the SRC folder. In the SRC folder, when React comes with this setup, like an assets folder, app.css file, we also have app.jsx and also main.jsx. Main.jsx is the main entry point of your application that will render your entire app. So there's a lot of things to do with React itself. Unless if you are not familiar with React, I believe you can get some tutorial to go through. But for now, I'll just show you how to build using React. So I believe our installation is complete. Yeah, it has installed everything. So if I do yarn dev, we have it running on port 5173. So I'll head over to my browser here, localhost port 5173. So this is a simple React application created with Vite, of course. So just it will help you see the basic setup of a React application. So this one is like a complete application. You can use this one to export to even a browser extension. But yeah, so in the setup, we have the count button, and this count button increases the value the moment we click on it. So we have a state variable that's tracking the value. So it's using use state. Count is the value, and the set count is a function that will set the new value of this given variable or this given sort of constant thing. But I couldn't take much time here, so let's go to what we need to do. So we have a contract, and from this contract, we need to read the value from the contract and increase the balance. So increase balance and get balance. Those are the two methods that we have. Those are the ones that we're going to deal with for now. So I'll head over to the terminal, stop the server, then install Starknet.js. And we have seen here installing Starknet.js is simply npm install Starknet. So that's what we're going to do. And here I'm going to just say yarn add because I'm using yarn, so yarn add Starknet. But if you're using npm install Starknet. So that's the first value. We have installed Starknet and we are ready to go. So I can just simply proceed and say yarn dev. And we have our server up and running. So I'll have to delete a few things here. I'll do like delete this one to, I change this one to hello Starknet smart contract. So this one, we call this one devnet, like that. Let's see what we have. So this is what we have, hello Starknet smart contract, of course, for devnet. Then we need to get rid of this and remain with a few functions. So we'll get rid of this. And we have our button there. I need to close this one correctly. So for this button, it's not going to be increase balance. I'm going to remove the on-click method first. And here I'm going to write, for example, here it will be get balance. And I will duplicate the same button to increase balance, like that. So we have the two methods or the two buttons ready, get balance and increase balance, that we are going to use now to achieve our various uh, stuff. So the first method is to get balance. So that's this a read method. So const get balance, and what's going to happen here? We are going to the first thing is to sort of initialize our contract or set up our contract. So const contract equals to new contract, and the contract we are going to import contract from Starknet like that, like the contract class. Then this contract class will require something called an ABI. It will also require the contract address, so something to do with contract address. And finally, if you have a provider or not. So here, a provider or account. So provider or account means either you pass in the provider value or an account value. For this case, we are going to pass in a provider value. So let's say provider here. So those are the three things that this contract will require. But how do we get the ABI, the contract address, and the provider? So we'll start by the ABI, then contract address. So the ABI, if you do recall, we did build our contract. And if we go back to the build of the contract we built, so I have to open this one again in VS Code for better view. I'll increase the font. If you go to the target folder, then dev, you'll find a few files here. The first file is called compiled contract class, and another one we have contract class. So I've avoided reading the hello Starknet values. Then finally we have the artifacts.json. Artifacts.json will show all the contracts you have. For example, in this case, we only have one contract called Hello Starknet. As I said, you can have several contracts in the same project setup. You don't have to like create different setups for different contracts. No, if you have a contract that uses the same values as another one, for example, same types, same everything, you need to use like as common or a shared module somewhere, then you can use a simple project setup to do different contracts. So artifacts will show you the number of contracts that you have. Currently, we have one according to the array len, and that's called Hello Starknet. That's the contract, and the Sierra file and the casting file. As I said, these are the ones that are deployed on chain for now to manage your contract itself. Like now, these are the ones to be invoked. They are the contract themselves. So our target here is this contract class. That's the Sierra file. That's where we are going to get our ABI from. And for those who don't know what an ABI is an application binary interface. For those who are familiar with the APIs, you can think them of as APIs, but they are not APIs. They are ABI, application binary interfaces, than the others. So these ones are just interfaces of your application. For example, they contain the functions, the events, the structs, and the other values about your contract. So let's obtain our ABI from the Sierra file. So I'll just go to contract class.json, contract underscore class, not the compiled contract class. And here I'm going to search for ABI. And if I search for it, you'll realize it will take me to this key here that has the ABI in it. And I'm going to select from the start of the array here to the end. So that's my ABI. If you realize it's the last key in the Sierra file, that's the contract underscore class file. So just find the value of the last key, that's the value of ABI. So copy from there to almost end except the closing bracket. Then after that, walk into your front end. Then here we had the assets folder. And in the assets folder, we have something like this. But here I'm also going to add a few files. So I'll just create abi.ts here. And here I'm going to export a single value, export const, and I'm going to export the ABI from this specific file like that. So this is our ABI. Currently it's not formatted like in the right way. So uh, another way for me to quickly format this, I'm just going to create a ABI, abi.json here, paste it, Control Shift I, Control A copy, and I'm just going to replace this value here. Don't like it being that way. I think this one is more clean and better. So this is our ABI. And if you look at this ABI, it has a few things. The first one is the interface. And this interface is called the Hello Starknet interface. If we go back to our contract, we can be able to find the interface here. Here's our interface. There, Hello Starknet. So it has been copied over to the ABI. Then next we have the interface values. So the interface values we have here is the type interface. The name is that Hello Starknet. The different items, that is the functions. So increase balance and get balance methods. And also we get something else called state mutability. So this get balance has only view values, and this state mutability is external to show you that you can be able to use it to write to the contract. So that's our ABI. The rest of the information includes the events, and sometimes you can find something called L1 handlers and all those other values. But what you for now we need is just this array containing a simple view of our contract. Like now, it's like a map of our contract. So we have an ABI. Next is the contract address. So we need to import our ABI first. So let me go here first. So I need to delete this one. We don't need it. I need to import the ABI from the ABI. So ABI, and it has been imported from assets ABI. Next, I'm going to create another file here. Actually, I don't need an extra file. I'll do it here. So const contract address equals to. So for our contract address, we have it already. We did save it in our send foundry. So I'm going to copy it and paste it here. Like that in a string format. Then finally we have the provider. So for provider, I'm going to create it here. Const, let me close the sidebar. Provider equals to new. We are going to use something called new RPC provider that is provided by Starknet. So we have already imported it here from Starknet. And in this case, it will want a few values or a few options for it to set up. And that is a node URL. And the node URL we're going to use here is the local node URL. That's the Starknet devnet URL. So HTTP localhost port 5050/RPC. That's our node URL. So we have our contract address there, and we also have the provider. So we have a new contract setup. So if I go ahead and console.log this contract, this is what we'll get. But how can we get to this or see the value? We need to call the method getBalance, and I'm going to call it on this function. So on click, then call the getBalance method. If I go to the browser again, open my developer tools, so inspect, right click inspect. I'm going to minimize this a bit for us to have a better, larger view. Then clear, then increase the font size too. So if I click get balance here, you'll see we have a contract here, and this contract has a date there. The address is set here. Some values or the methods have been written here, and other methods, including populate transaction, provider account, and other methods. But we'll only focus on what we want, that is get balance and increase balance methods. So we have the get balance, we need to complete it. So how do we call our contract? What we do here is const, not really const, but rather we are going to do contract dot get balance. That's a method that we know exists in the contract class because we have seen it here, get balance. After that, we are going to call use callback values here, the result, which can be anything, and we just do console.log. Actually, it's using .gsx. I thought I'd gone with TypeScript. Okay, my bad. That's why I have the any value here. Don't need it. And also this we had the api.ts. It's good if you are just on JavaScript environment, use JavaScript values only. Yeah. So we are going to console.log the result. So contract call result is, and we pass in the value, the rest there. Otherwise, we catch the error, and we also console.error, and here contract call error is, if there's an error, it's going to be console logged out there. So we have this one set up, so we'll just add more spaces for visibility purposes. So that's contract.getBalance. We know we have this method, then the result, we want to console log out the result, otherwise catch the error. So let's try out our method. So I'm going to get to our browser again, then click get balance. You realize we call it and we get contract call result is 2n, meaning it has been able to read the balance from our contract. So that's how you read contract values. When reading from a contract, you don't need an account. That's why we haven't set up an account here, but we'll set it up in the next moment. Are there any questions up to there? Okay, right. So that's how you get or you read from your contract. What if we had some value like call data or parameters that we needed to pass to the get balance method? You only need to pass them here. For example, maybe if we needed to pass in the page, we can just say page 1 and that is it. You don't really have to struggle much about passing values, so easy like that. Before we just now wrap up on get balance, I will go ahead and do the increase balance method, and then we'll come back to update our UI to show the difference balance, because of course the user cannot go to the console to see the balance. The user has to view the balance somewhere. So I'm just going to duplicate this method again, and then instead of get, I'm going to write increase balance. We have our contract here already, except the provider will change a bit. So we need to create an account. For this case, I'm going to do an account here, const account equals to new account. Also, we need to import account from Starknet, and this account will require options. That includes an address. And let's see, if I go to the account method here, it will require an address, and also, yeah, it will require an address and also a private key to do the signing, PK or signer, that's what's called. And also it will require a provider. So we need to pass in the provider here. The next we need to pass in account address, and account address, I think I'll write them somewhere here so that they can be together. So const account address equals to that, and also const accounts private. Actually, let's just call them private key. Don't really need to. So account address and a private key. Let's get them from Starknet DevNet. So Starknet DevNet, I'm going to take this account 2 here, control copy, paste here for account, and also for the private key, we need to get it from Starknet DevNet, so don't need this extra terminal, the private key like that, paste it there. Remember, this is very wrong. Don't store your private keys in your source code. Better use environment variables if that's the case. Otherwise, you'll end up losing your funds in one way or the other, because you will use the same account again, maybe to ask somebody to send you some funds. Then that's how your money goes. So avoid this at all costs. Use environment variables. For Vite, it has a way of doing that. For Next.js, it has a way. For React itself, it has a way of achieving it. So find a way of it doing it. Then we need to pass, we go to the account, we need to pass in the address. So account address, like that. And we only need to pass in the private key. And then when we are initializing our contract or connecting our contract, we need to pass in the account like that. So this one way. The other way is we have this account like this. We do something like contract.connect. So you just do something like contract.connect, and we need to connect an account like that. That's how you connect an account. If you didn't want to, for example, here you only had a provider like this. So you can connect your account like that. Why connect an account to a contract? So this account is going to sign this given transaction. For now, I'm not going to use the connect. I'm just going to pass in here account. So this is what I was talking about when I said provider or account. That's what is required. Provider or account. So in this case, we have passed in an account, but this account has taken in the provider, meaning we have passed in the provider in one way or the other. Yeah. So we have our contract here, contract dot, and in this case, we are going to call the method increase balance. And this balance, we are going to increase it by 2. And then we wait and then listen for the result. Otherwise, we proceed to log out the error. So we need to call this method also here in increase balance. So method on click, we want to increase the balance. So I'll go back to the browser here. So get balance first, we have to increase balance. We get a transaction hash back. So this is what we saw when we were interacting with it on the terminal or on shell. Now, if we get our balance, we find it is 4n. So far, so good. We have our transaction hash back. We are able to increase balance. We are able to get our balance. Next, so next is to display the result to the user, what has happened. Now, the user can't go to the console as we have done. So let's display the balance somewhere here. So I can just come here and do like text. So that's a paragraph tag, and say current balance is, that's where we'll be displaying the current balance. So I'm going to write their balance, but we don't have balance key. We need to have it somewhere. So that's where we are going to use the useState hook again. So here I'm going to set balance, and by default we are going to start by null because we don't have any balance, or we are just starting from an undefined state. Then after that, we are going to log out the balance here. So contract balance is, so balance, we want to display out the balance if there's balance. Otherwise, if there's no balance, we just need to do a dash. So that's what we expect to see. We only need to see a dash here. Then after that, we just get the balance. So contract, we have the result, which is the balance that we expect. So we can just do set balance, and we do balance like that. Then for increase balance, nothing there, so we just leave it like that. So we try to get the balance. So it's going to do what's going to do, like get the balance, and I try to set the balance up. So let's see why it's failing. So we are getting an error, uncaught balance is not defined, and such like error. I'm not sure where. Balance. Yep. So I'll just reload the page in order to make sure. So get balance, it's going to load and I try to get the balance. I'm not sure it's not setting the balance, so let's get balance method. Oh, actually it should be res, not null. Yeah, we are setting the balance to the result. So get balance, we have here 4. But if we were to console log out the balance here, or the result, you realize it's not really 4, but 4n. What is 4n? 4n is a big int that you need to convert to a normal int. So usually what you can use here, first you can use something like a past int or a big number.js. So I'll just show you how to use big number.js. So I'm not sure whether it is installed here. So let's try to import big number from big number.js. Okay, it's not installed, so let's install big number.js library to help us do that. Control C, clear, yarn, add big number.js. So this is for big numbers, or rather most of the numbers that you are going to get back from Starknet. This includes U256, U8 to U256. The reason as to why you might need to use big number is because it will allow you to convert even large numbers, but pass int can only pass to a given value, max value. So here I'm going to set res to the new value, const new res equals to new big number, and here I'm going to pass in res dot to string. I'm using dot to string, but there are other methods that you can use to have it. So if I do like that and I try to get balance, so it will print out 4, but not 4n. This is good for even large numbers. So, and a big number can help you calculate even heavy complex multiplication. So big number dot multiplied by, so 10 to the power of 18. So this is when you want to convert a given value to the value, the expected or the right value of Starknet or so, then you can call the dot string method there. So some values like this. So this is for it because it has 18, or for stack because stack has 18 decimal. So that's how you get your for it, your for stack, or that's how you create these large numbers easily. But for this case, we are not going to use the dot multiplied to. We are only interested in the dot to string method to convert our big number to the right big number. So get balance is 4. So if I increase the balance again, we have our transaction hash back, and I get balance, I have 6. What happens if you have a transaction hash like this? So there's another method called wait for transaction, and this is what our wallets use. When you make a transaction, it just goes in. Yes, it successfully goes in, but it has not been processed, because if you do recall back when we started off in class, in the second session, we did talk about the sequences and all those other stuff. So first, the transaction goes to the mempool, then it's picked from there, then processed. So for you to make sure the user does not exit the page before your transaction is fully committed, you have to sort of, if you have time, wait for the transaction. So this method, I'm just going to write it within here, and this one actually it's under the decrease balance. So we know we can get the transaction hash, const tx hash equals to res dot transaction hash. Transaction hash, how is it written? Yeah, underscore hash. Then what you can do, use the provider method. So const result or tx result. So I'm going to call this one result equals to provider dot wait for transaction. And here we only need to pass in the transaction hash. So tx hash like that. But this is a promise that we'll need to resolve. So I'm just going to use here await. And await cannot be used inside a function that's not async, so include async there. Okay, this does not seem to be needing all those. So we have the TX result. So we can just go ahead and console log out the TX result, TX result. Let's see what we have. If there are any errors, we'll catch them. So increase balance. So TX result, this is still pending and all those other stuff. So that's why I said we need to await for it. I have opened the wrong tool here, so I'm going to just exit. So I'll just write the await method, but you cannot use await inside something like this. So I'll just convert everything to be async. So const result or res equals to that. I'll just await here so that I can be able to, and then this one, I can move them up like that. Okay. Okay. I need to move this one out first. Then delete most of this like that. Then I'll just move this one to the place where they, so, and we have said const tx hash equals to res dot transaction hash like that. So we just do this and wait for the transaction. If it's finished correctly, then you can be able to see the value. So get balance, we have 8, increase balance. So it's going to just wait for the 2, then print them for us here. Yeah, we have the TX result. So what we get from this transaction, it includes the events that will be emitted. And for this case, we have from address, for example, we have this event and another event here, that is this one. That is from address. I think this from address 0x49 should be ours. Not really. So some events will include sending funds your gas fee to Ethereum mainnet, or now like send out the information. But there are a few more things here we can read from here. The actual fee is in way, and that's the actual fee. And also we have the block hash, block number, the events. We also have the execution resources and all those other stuff, and the other information about that uh, specific call. So that's how you listen for events. And then, in other words, you can also sort of go ahead and use another method called, that is on the contract, of course, that is const events. Events equals to, we had our contract here, dot pass events. And this one will require a receipt or a transaction response. And then we can just pass in the transaction response like that. Then we can console.log the events. So events are also useful when you are doing indexing of your contract, and they are the ones that help more explorers to index the information about a given chain. So I just get balance. Now we have 10. If I hit increase balance, so it's going to take its time, but it will finally now give us passed down events. So we give it a few more seconds. There we go. So we have the receipt there, and it will pass the events based on the contract itself. So we had this event called Hello Starknet Increase Balance event, and that's how you see the event being executed. So I told you, like, using the terminal, it's hard to see whether an event has been emitted, but now with Starknet.js, you can be able to see all the past events based on your contract. So we have our event there. I don't even know where to start asking the questions from, but I'm following. So you can ask from anywhere, because I think I'm going through a number of things. So just asking a question from any point will be helpful. We can iterate back over there and cover it well. So that's for an event. So I'll just do a quick recap. For our get balance method here calls the get balance method on our contract, and this our get balance method on the contract, and this how it looks like. It only returns the balance from storage, what is stored in storage. Our increase balance method will adjust the balance in storage, and also it will emit an event called increase balance event that we have here. So if we go to the front end, get balance, so we create a new contract here. New contract, we pass in the ABI, and we have said to obtain your ABI, go to your contract, go to the dev or the target folder, dev folder, then find the contract class. Hello, okay. So just look at the contract underscore class.json file. From there, if you scroll to the bottom, to the end, find a key with the ABI. The best way if you are on VS Code, just find ABI. It's usually not lots of them. So except the ones that are having statement build. Otherwise, use the advanced regex there that's given by VS Code. So make sure you are searching for AA, AB from anything that matches exactly this and anything that is exactly this. That's the one. That's for regex stuff. Then from there, copy the value here that you get there to the end. So from there, the opening square bracket to the last square, to the second last character, that's the square bracket there. Of course, the last square bracket in that page. That's where you get your ABI from. Then after you have your ABI there, go and save it somewhere so that you can import it to your contract as an ABI. So here, I only import it like that ABI. Then make sure you have your contract address ready and also set up a provider. And the provider we are setting up here is a single provider, new RPC provider, and we pass in the node URL. And that's it actually even for Sepolia and the mainnet. You change this one from the local host, you set this one to Blast API, Juno, we have Alchemy, we have Infura, for those networks, of course. After that, you call your method contract.getBalance, and this method that you are calling will return a promise, and we need to resolve the promise, or rather listen or complete the promise correctly to get the exact value. So we use the .10 method on it to get the exact balance or to get the exact result if there is any, and .catch to catch any errors that might arise. This other method will also work, but if anything went south here, somewhere here, so let me just completely make this one fail. So if anything went south, you won't be able to catch that specific error. It will simply just fail. So to avoid such failures, there are other options you can do. So that's a failure that just happened somewhere. You can use something called try catch block, and the try catch block will help you uh, catch help you handle errors in the right way. So that you can maybe say console.log error, and then you can just say something like this. So that's the work of try catch. So it will just sort of do that exactly. But now you have been able to manage the error. So this is error handling. You handle the error on your own. Otherwise, without the try catch and without maybe using this method, a promise, resolve, and all those, then you'll just find yourself having something that fails. So I'll leave my try catch block there and change my value here like that. So we have only been able to get increased balance and all those things, but we have only hard coded the value that we are increasing the balance with. Usually what you do is you have to listen for user inputs. For this case, I'm going to put it simple like this, const amount, set amount. So this is how you'll be reading it from your form. First, you have maybe a form. use state, and here maybe you start by maybe null also. Then here in increase or in your try catch block, you just make sure if amount, if there's an amount that you want to increase with, then you proceed with to increase the value with that specific amount. Because we started with the zero here or with the null, it won't call that method unless we have an amount. So if I try to even try to, okay, the current balance is 13. So if I try to increase balance, it will just be there relaxing. And I think I will just change the way I've called this one so that we can make it more professional a bit. And here I'm just going, if there's no amount, alert, an amount is required, is required. This could just be simply that easy, but I don't like it. So let me just alert there. Amount is required. Then after that, I return. I just want to return something so that it will break at that specific point. So if I try to do that one, amount is required, okay, it doesn't proceed. So let's actually do an amount value here. So I'm going to write another input here. It's going to be styled. So input value equals to amount on change equals to event, of course, set amount to dot target dot value. Then if I come here and say maybe I want to increase by 2, then I hit increase balance. So it's going to increase balance, not like it's going to fail. Now we head that in. So we give it a moment till it finishes going through the function. Now we have our event back. Then get balance. Now we have 15. I can simply jump to 5, increase balance. We expect 20 at the end of this function call. So we wait for the transaction to finish. So here's where you do your load that stuff and get balance. So we have 20. Yeah, so that's how it goes. So you read an input, maybe after the balance has been increased or something has happened, then you can just clear your inputs so that a user can't repeat the same or send the same values again. So that's smart contract interaction or integrating your contract to the front end. Any questions? If you have some, kindly drop them. So in this case, for this case, I'm going to illustrate another tool. This is just a tool to help you quickly iterate over your contract and test it out quickly without like having issues. Where is the balance displaying on your screen? Next question. So in my screen, okay. Oh, the balance is so small. Sorry for that. So I'll have to zoom this one in. There we have our balance 20. I think I will just increase the font size. So just a moment. Current balance. I do style. Font size. We just need something like 42 pixels here. We want this really visible. Yeah, we have 20 here. So if I increase this one by 1, increase balance, so it's going to increase by 1. Then we have our loader going. I believe the loader is done, so let's get balance. We have 21. So that's how it goes. So, and the way we have displayed it out is, zoom out a bit for visibility. We have the balance here and the set balance method. If you are familiar with the React, we are using a use state hook here. So it gives us a setter method, and of course this can be a getter method, but now it's a value. Then we can get the balance, then we set the new balance. That's when we go ahead and display the balance here if there is any balance. Otherwise, we only display a dash to show that we have loaded our application. So that's usually good. When somebody just reloads the page, they shouldn't be seeing here 0 because that's not their balance. Just show them a dash. There's no balance. When they get the balance, they have their 21. So that is for this simple contract interaction. I couldn't do a complex contract because of time and also to make things easier and simple. But there are other tools that you'll need to learn or to know about as you go on. And I think it's good for me to introduce them right now. The first tool is called Starknet Kit. It's also a JavaScript library built for Starknet that allows you to connect wallets. You do recall the connect wallet button here, for example, this one on their website. So this one is done by Starknet Kit. So if I click this, you'll need to have this in your contract. How do will people to connect their wallet? So Starknet Kit is the first tool. The next tool is called React Starknet. Starknet React actually, not React Starknet, Starknet React. Go there and find Starknet React. What's Starknet React? Unlike Starknet Kit only helps you manage your wallet accounts or your accounts. For Starknet React, is more of a VM. We have VM and there is another library. I have forgotten its name. Common in Ethereum development that provides you with a number of hooks that you can use. So this one will provide us with a hook like a use contract. And the use contract is good because we only need to pass in the API. For example, here, contract, use contract. Now, at the end of the day, it will return a contract that we can be able to do contract dot get balance, contract dot increase balance, rather than doing like new contract whenever you to do it. So these are the two tools that you'll want to have. So I'm going to quickly go through this one. This is use contracts. Oh, okay, I need to get started. So this Starknet React, and to set up Starknet React, you'll need to have all these values. So public provider, how do you get the public provider? So this is the setup process. Just go through it. It's not like that uh, heavy to go through it. Then it will give you like now the easier interaction of your contract without having much values. For Starknet Kit, you only need to do npm install Starknet Kit, yarn Starknet Kit. Then you will call a few methods from it that includes connect and disconnect method. So connect to connect, it will open up a pop-up like this to connect a wallet, and it will return back a wallet account, and disconnect to disconnect your wallet. So that's like Web3.js thing and all those things. Connect, disconnect. I'll just go ahead and illustrate some other tool that is very helpful as much as it's in development, but it's being maintained. It's called Stack Deployer, but this is for iteration and development of contracts. So I'm going to, so the link is stack-deployer.versal.app, not yet fully in production. So what does this do? The entire process that we have done here of deploying our contract and interacting with it from the terminal was quite cool. But what if you wanted to quickly iterate over your contract? You don't want to just come here, or you want to test out your contract. You can use a SendForge test visually. So you can use a tool like Stack Deployer. Here I can come in and deploy a contract, and maybe call this one Hello Starknet. That's the name of my contract. I'm going to pick two files. The first one is compiled contract class, and another one is construct underscore class. Those files that we just illustrated here that are fileable under dev. What if you don't have the files? There's only one reason. You have to come back to your scab.toml file, set up Sierra to true and Casm to true. Have those ready. Then come back here, make sure your devnet is running, otherwise this one is going to be off. Here I'm going to go to frontends. We'll go back, hello Starknet, target, dev, compiled contract class, and also I have session 4, hello Starknet, target, dev, contract class. Then I don't have any call data from a constructor, or I don't have a constructor, so I can just hit deploy. Once you click the deploy, it will bring back like a declared class hash. If you do recall, we had a class hash, so you can take this class hash. Otherwise, the same class hash, it's the same class hash that we have here. So I'll just try to declare this contract again. Yeah, it will fail, but it will return the same class hash 0x066. Then it ends with 56 is in 9. That's what we have. Then I can hit now deploy. Yeah, I think the other method should be declare deploy. Yeah. So it's going to deploy the contract. We give it a few seconds. I'm not sure why this is taking its time so much like that. This is a progress event. This doesn't sound good. So I'll have to reload the page and set it up correctly. Yeah. So it has deployed our contract and it has redirected us to the contract. What if it didn't? You can be able to find your latest contract, of course, there. So I have given more instructions on how to make sure you have the same contracts whenever you are using this DevNet. So yeah. So if I go to contract, I have my contract there. I can be able to interact with it. I can get balance. So we expect to have our 21, I believe. Oh, actually, this is a new contract, not like the old contract. So we have our 0 because this is a new contract. Then I can increase the balance by something like 10 and increase the balance. I have my 10, my transaction hash. So if I get balance, I expect to get a 10, but I'm getting an A. So these are big ints. So big int A, that's what it means, big int 10. So that's how you see the values. The first one was 0, the other one was 10. So if I increase this again by maybe 1, make call, then get balance, now I expect another value B, then I have my 11 there, big int 11. So that's how it goes. So this is just a testing and a development tool to help you quickly uh, get you up and running. Also, you can have your API from this direct file or from this link. So I can click there, copy my API. I have my API, then I can go and set it up in my front end easily like that. So I can walk right to my front end, API.js, replace everything that goes in there, delete, and paste. So I have the same thing that we had before, except in a more efficient way. So that is interaction with the DevNet, illustrated using Starknet tools here. That is Starknet. We have here Starknet JS and yeah, Starknet JS. So the next portion is deployment to Sepolia, and also deployment to Sepolia will be the same as deployment to a mainnet. So take care of be keen in this so that you can have your contract well taken care of in both the environments. So when we were deploying to DevNet, we did add an Open Zeppelin account and we did declare it like that. But what if we want to deploy to Sepolia? So to Sepolia, you can add a same account. For example, here SNCast account add. So let me try to find my function or my command. I think this is the one, but I need to have like this the address and the private key. Public key is the same as address at some point. So And the type here can be either agent or Bravos, then add the profile. Then proceed with the normal settings. Remember to change the URL here to point to Sepolia RPC. A Sepolia RPC, as I said, you can get them from somewhere like Juno RPC, so public node. So you can use Juno. Alafu and also we have Starknet Blast API where you can be able to find it. A Blast API for Starknet. These are open source. Use V7, don't use V6. V6 might be having some issues. So this for mainnet. Otherwise, just change this one Starknet mainnet to Sepolia and you are good to go. Those are the two. Okay, actually not this one. Juno, okay, Starknet, Juno, RPC. So it's under the Juno stuff and all those things. So you have it here. Just go to, I think it should be, okay, it's like really far to get. So let me just type the easiest way to get there. So go to voyager.online, then head over to, I see it's my account. We have something like, yeah, here it is, access Starknet RPC. Yeah, data.voyager.online, then click on docs, then it will take you docs.data.voyager.online. Then you have your Juno RPC there. And so we have talked about Blast API, Juno, and also we have Infura. So Infura will give you those. Just select Starknet network and also Alchemy. They will give you the two, or yeah, the two RPC endpoints for mainnet and testnet, just enough for your testing and even for quite an interaction for your application. So that's how you get RPC endpoints. So once you have your RPC endpoint, replace it there, then account add the address and the private key. So as I said, this is not like the best way of doing it because sometimes you find the same address on Sepolia can be the same as on mainnet, and you end up losing your assets. So using tools or the terminal quite good, but not the best option. So for deployment, you can use, we have here AgentX. AgentX in it has a developer, a place where you can deploy your contracts. So hit there. For example, go to AgentX, then click on the settings, then developer settings. Then here we have deployment data or smart contract development. Click smart contract development, then declare smart contract. So here I'm going to select the smart contract I'm going to declare. So I'll select the compiled class, but yeah, so it will just sort of exit because you moved out of the extension. So what you need to do first, make sure you open the extended view like that. So in the extended view here, let me try to increase the font here. Also, now you can proceed to do settings, developer settings, smart contract development, declare smart contract. You are asked to upload contract class JSON. So I'm not sure, I think that's the one. Then you are asked to upload the compiled contract class JSON. Compiled contract is now compiled contract class. Then you select that. You select the network to Sepolia, otherwise you can select any of these. Provided for DevNet, you make sure you have your server up and running. Then after that, select your account like that. Then deploy or declare. So it's going to declare your contract. After declaration, that's where we are right now. It will ask you, do you want to deploy your contract? So just copy the class hash, very critical. Then proceed to paste in your class hash. Then select the network, Sepolia, of course, the account, that one. And they're asking, do you want a unique address? So you can ask for a unique address and all those things. Otherwise, just don't pass in the salt, just hit deploy. It's going to calculate the fee, then it will deploy for you your contract. Then after that, you'll get your contract deployed with address, have your contract address there, copy. From there, you can proceed to tools like now voyager.online, voyager.online. click switch to Sepolia, then search for your contract. So sometimes you might miss it because it has not like been indexed, but it usually takes a few seconds. So currently there's nothing here, but we have the code here, and also we have the read contract. So the contract not yet, it's not yet active. So give it a few more seconds, reload the page and see whether it has given you all the expected values. So we'll get back to this once it is like deployed or the transaction is fully processed. So I'm going to go to stack-deploy.vassal.app, go back to the main page. So from the main page too, you can be able to deploy your contract the way we have done on AgentX. So here I'm going to pass in. Actually, I'm not going to start by deploying because we have already deployed our contract here. Let me just reload this one to confirm whether it's here. Yeah, our contract is back, so we can be able to read the balance query. I expect some value, contract address, something, contract not found. Contract not found. What contract is this? 0x04DS6. Is that? I think it should have called this one. Why is it calling the other one? Okay. I'm having some few issues, but let's hope they'll be sorted. So what I'm going to do here, I'm going to just import my contract. So my contract is called Hello Starknet. Remember, you have to be connected to testnet or Sepolia, that's the thing. Then import. So it's going to import our contract if it's available. Otherwise, it won't import a contract that does not exist. So for this case, the contract does not exist. So this is the right contract address. I need to copy this, not this one. This one was for our account. Also, I'm not sure what's really happening here, but seems to be failing terribly. So I'll have to reload my page and try to import it again. Okay, or if do I have it? No. So these are other contracts, not this one. So I'm not sure whether the contract was deployed or not, but I think I can move to StackScan and see what happened. So StackScan is another one, or you can use BlockFire, Sepolia, then search my contract. It's saying this is my contract. Read class, read write. So we have the get balance. I can query it to get 0 because we haven't like passed anything. Then on the right, I need to connect my wallet. So I'm going to connect AgentX. Connect, done, done. So I need to go back to StackScan here. I think I'm connected. Yes, I'm going to increase the balance by 2, right? So confirm. Yeah. So we go back to read, get balance, query, expect my 2. Yeah, we have it here. So the only catch, I don't know why it's unable to find this contract. So I'll disconnect my wallet and connect AgentX to see whether it will be able to identify the contract. Unable to get the contract exception. Importing contract, Starknet get class at with these parameters, contract not found. I'm getting the same error as Voyager. So I think this can be an issue with the RPC that I've connected. So we might need to change this one to another RPC. So I'll just take a moment to get my RPC here up and running quickly. Paste. Paste. This one should be mainnet. connect Agentex, then try to do them. Yeah. So sounds like Jujuno RPC is not responding currently, but yeah. So I have that one imported, then I can click interact, then I have the same method. So currently we have interacted or added two, then we have our two there. Increase balance, we can increase by two, we have it. So that's how to like use StackScan and and how to deploy your contract using Agentex. That's on Sepolia, same for mainnet. But as I said, you can also use this deployer to deploy your contract. Just select the casing file and select the Sierra file, then pass in the contract name, Starknet2, no call data, declare. So it has its own problems here and it's failing with its own reason. So I'll just disconnect this one, connect to another wallet, and proceed with my deployment stuff. Yeah, Agentex can give you some headaches here and there, but you'll have your Hello Starknet 2 contract deployed and you can immediately go ahead and interact with it. So get balance, this should return 0 if the contract is available. Then if I increase the balance, that should work as expected. Get balance, we should be able to get a 1. So of course it has not increased. So this is the difference between the two. So DevNet can be quite fast as compared to as a poly or mainnet. So you have to give it a few more seconds for it to return the correct value or for the transaction to be processed, but that's it. Don't know how much time we have, but we can just check out something else if there are no questions. Okay. Yes. Okay. So we have seen how to use or interact with our contract on DevNet, but we haven't seen how to interact with our contract on Sepolia or on on Sepolia or
Excuse me, Dalmas.
yes.
Yeah, just for the sake of those who are probably new in Web3, maybe you can explain the essence of having the contract ABI. What does it facilitate the ABI? Because probably there are some people who really don't even understand what ABI is all about.
Okay. So good question there, Harriet. So an ABI, as I said, is an application binary interface. For example, we have APIs that we are used to. For example, an API to interact with Twitter. For example, I wanted to read tweets from a given account from Twitter. I don't have to go and scrape Twitter to get those tweets. There's an API they provide. Uh, Yeah, so an API is just an application programming interface. They provide for you to read those tweets or posts from a given account. And that's so common for the rest of the Web2 applications. So every Web2 application, at least behind it, there's an API running things. So an API will help interact or call another server, interact with another server for data or to post some data. So that's how applications communicate in Web2. So different applications can communicate using API. Of course, that's one of the ways. There are other methods applications interact with each other in Web2. For example, your application, normal application, interacting with the Facebook API to run an ad, interacting with the Facebook API to read some posts and all those things. So we use the application programming interface. But what happens in Web3? So an API is the best way of interacting with other contracts or with your contract in Web3. That's the application binary uh, interface. Yeah. So the ABI will help you interact with your contract. It's like a blueprint to your contract. For example, an API that goes to Twitter to read posts, maybe it's to x.com/read posts. That's the API endpoint. But what about when it comes to blockchain? You'll need to have like a similar way of things, but for this case, you'll need the address, the contract address, of course, and that blueprint of the contract you want to interact with, so that the provider or the RPC can be able to know exactly what method you want to call. And also, it's good for you. It helps achieve a number of things on the front end. For example, ABIs, there's a way you can configure your ABIs, so you can get auto completion of methods when you are writing your front end. For example, I could have just started typing contract dot, then it shows me the methods that I can call on that given contract. So that's the importance of an ABI. Also, as I've said, it's also a way for other contracts on the same chain, of course, to talk to each other. So the same way we call the contract from the front end, for example, here we have said get balance from the front end, is the same way another contract, or you can call another contract within a contract to get the same balance. So it's the ABI that facilitates that. For example, it provides the interface or the expected functions, expected events, expected structs, in this case for Starknet, expected interfaces, or how the contract will look like. And usually you don't have to get all the methods there in your ABI. Maybe you only need 2 methods, 3 methods. So just focus on those 2, 3 methods that you want for that specific function, for that specific contract. That's another thing that is in Starknet. You don't really have to have the exact entire ABI for a given contract. If a contract has 45 functions, for example, the a stack token contract, something like 45 functions, you don't need to have an ABI having all those 45 functions. No, you only need an ABI having the exact functions you want to interact with. So if you only want 2 functions, 3 functions, that's what you'll call. So can just find it. Hello, cycle stack. Yeah. So if you look at this, it has about 43 functions. Do you really need all this? No. So the ABI will also help you filter out the exact functions you want before you include them in your contract, in your front end, because every byte uh, has something to say. It increases the bundle size. So something like this, and you only need maybe approve, you'll only get one of those functions. So that's the work of the API. Get some functions for a given contract, or get some value, some segment of a given contract that you want to interact with for that specific contract. Okay, so we'll get back to my notes here. We see what we haven't covered so that we can. So we have covered events in Cairo, writing a simple contract. We had that one. We had already done that one. Deploying the contract to local testnet. We have already achieved that one using these different methods here. That includes starting from SNCast declare, SNCast deploy, SNCast invoke, and SNCast call. And also we have linked it to our front end, except you have only linked the normal DevNet contract. We haven't linked the entire Sepolia or mainnet contract. And also we have gone ahead to learn more about the libraries and tools used. We have talked more about Starknet.js, what we need from it, the RPC provided the contract, the account. We have also seen how to set up or interact or create a new account, a new contract, and a new account and a new RPC provider. So those are all covered. That is account, contract, and RPC provider. Then we have gone ahead to call our contract using a read method. That's get balance, contract.get balance. Then we did get the value. Then we have gone ahead to post the or to write the contract. And here we did introduce Starknet Kit. So we said Starknet Kit will help you now connect your real wallets that includes Gentex and Bravos. That's what I've used in Starknet Player. So for it, it's just a toolkit for building applications on Starknet. It simplifies the process of connecting and interacting with Starknet smart contract. So that's Starknet Kit. Benefits and the key features. Utilities for interacting with Starknet's contract. It simplifies contract calls and interaction. So with Starknet Kit, you are able to open your wallet, sign a transaction, and all of those things. Then we went ahead, did a brief introduction to Starknet React, and we said it's one of the best libraries in Starknet that gives you out of the box hooks that will help you interact with your contract. So provides React hooks and a component for interacting with Starknet smart contracts. It also simplifies connecting to Starknet, reading from and writing to contracts, and also managing state in React applications. So a great tool for your frontend. So what are the advantages of building interactive frontends? So clean and intuitive API for integrating to Starknet functionality. It manages state and updates in UI response to contract events. It simplifies user authentication and also transaction handling. So for example, we said for Starknet React, here we have gone ahead and did or done new contract, new RPC provider, new account. What if you didn't have to do all this stuff? Use Starknet React, just wrap your entire application in Starknet React. So that's what was here. Where yeah, so you only need to do npm init Starknet. Yeah, we have a yarn create Starknet. So if you use this command, it will scaffold a project using Starknet React that has everything for you set up Starknet wise. That includes how you can interact and proceed with the calling or writing to your contract. Otherwise, you can manually set it up, of which the manual setup can be hectic. So I did prefer going to yarn create Starknet. So I think this is the fastest. So I'll just copy this and let's see what we have. I'll walk right to my frontends and a new open Stack. Okay, yarn create Starknet. So what's the name of your project? I'm going to call this one Hello Starknet React. Do you want to use Vite or Next.js? I will go with the Vite, then it's going to do the installation. So it will take its time, so I'll leave it there. When it will complete, we'll get back. Then wrap your entire application. This is if you were to do like manual setup and all those. Otherwise, with them, it's kind of easy and quick. They have explained step-to-step way of achieving everything that you want to achieve. Then it has very nice hooks here. Use contract hook to help us avoid having the new contract anywhere that we want. After that, we have use contract factory, helpful when you are doing like a contract that will help you will be you want to have a contract, for example, an ERC20 contract that you want anybody to deploy a token using, or an NFT contract. Then going down, there are other several useful hooks that you can use. Use contract type and use contract read, I believe. They are all here. So use actually to use contract, not use contract read. Use those hooks to make your front end interactive and quite good. Then going next through our notes here. So that's for Starknet React. Let me confirm whether it's done during the installation. Not yet. So we'll get back there and see what it looks like. Then setting up Starknet React, you can either do the manual setup or the auto setup that they have given us, yarn create Starknet. So here is your exercise. Integrate a deployed contract with a front end. Set up a new React project, install Starknet Kit and Starknet React, write a smart contract and deploy it to the Starknet testnet, create a React component to interact with the deployed contract, implement functionality to read and write to the contract, test the front-end application to ensure it correctly interacts with the smart contract, and then finally share the contract with us, deploy the contract to either Vercel. We also have Firebase. We also have GitHub pages. We also have the other one, Netlify. Yeah. So after you have done that, create a simple contract, create a front end for it, create a link for us to see, and post it, share it to the link that was given. That's hello at bchain with your name, of course. Just a simple contract. It can be what we have done today, or what we have covered today, or something that you decide to write, maybe your calculate application, something like that. Then share with us. That's the email is, I believe, Harriet. If you are in the call, kindly you can drop it in the chat. People to share their exercises with, or something like that. So just share a front end with us. They play to Vercel. That's the easiest and fastest. Or Netlify, I believe, but Netlify can give you headaches. So Vercel or Firebase, if you are familiar with the Firebase. Importance of testnets. So why did we have a local developments node and also maybe Sepolia to mainnet? So testnets are alternative blockchains used for testing and development. They mimic the mainnet but do not carry any real economic value. So why are testnets critical? It's a safe environment. It allows developers to test new features and smart contracts without risking real funds. So imagine you were testing your contract and then you realized, okay, I've been sending funds to the contract, but I can't withdraw, and you don't have upgradability functionality in your contract. If it were to be on mainnet, your funds will remain in the contract. Nobody will ever get them. So that's where testnets are here. Safe environment for you to quickly test your um, application. Another reason as to why we use testnets is cost effectiveness. Transactions on testnets do not require real cryptocurrency, making it cheaper to test. So you don't really need to have some USD for you to test your contract. Realistic testing, so it allows you to mimic the exact environment that will go to mainnet. So provides a realistic environment to test the behavior of smart contracts and applications under similar conditions to mainnet. So that's the importance. And like what we do in Web2 development, where you just build your API, find a tester to test your API, find a security expert to do all those things. So at least for this, you can do this for yourself. Of course, in Web2, you can do or achieve that one, but you might find yourself, your application is already on mainnet or in production before you even finish testing. So blockchains give you the testing to do realistic testing. If I was to send these funds, what would have happened? Will this event be emitted or not? Going forward, we have covered the steps to deploy to Sepolia testnet, and in this case, I've only showed you to use Agentex or a Stack deployer, but I'd also explained a bit about using your terminal, and I said it will be possible for you to do it, but I don't recommend it because you might end up exposing your private keys, and that's very dangerous. For those who have lost assets in the same way, they can explain deeper. So, or if you want to go with that one, just use the sncast command. The URL in this case, it's not localhost, but rather now one from Likemin, Fura, Blast, original. Then you proceed to do the rest of the values there, public key and all those things. Just pass all those. Except the public key, you won't be passing this one in. So you will only need to have your private key and your address. And those one you can get them from the wallet. So if you go to your wallet, you'll be able to find them. For example, if it's Agentex, click there, go to your account. So not really here. There, click there. Then you have your export your private key. Not a good idea. Same for Bravos. Go to Bravos account, click on settings, show private key. You have your private key there. So copy those and proceed. Otherwise, there's another better method of doing that one, and it's called use a Sncast account command. This has other methods to do it. The add will only add an existing account to Open Zeppelin accounts, that file of that follows the Open Zeppelin rules. Otherwise, use the create method, and this one will help you create a new account. After you have created your new account, so this you can create a new account. So sendcast account create dash dash help. After you have created your new account, it will require a name and the type that you want to create, whether to use agent or bravos. Then after that, you just add the profile. So sncast account create dash dash name. So I'm going to call this one. Let me call this one bravos. Name bravos dash dash type bravos dash dash add profile. And in this case, I'm adding the profile called bravos. Oh, okay, I'd forgotten to pass in my URL. So remember to pass in the right URL there. Otherwise, this command will run using the default URL that we have here, that's localhost. So I'm going to copy my URL from here. So just a moment. I'm on Sepolia, so I'll copy that one and paste it there. So you can do this. It will create an account for you. It will give you back the address. So you have your address here. You need to pre-fill this address or fund this specific address, which is not like so account successfully created. Pre-fund generated address with at least this max fee. So that's the thing. So you have to create an address. So this is an Agentex address. So if I were to copy a Travos wallet address, if I were to copy this and go to StackScan here and search for it, I should be able to find it. It's not yet here. Is it really? Let me confirm the URL. Yeah, it's on Spolia. So it can take a few seconds for it to reflect, but it should reflect at least. I'm not sure it's not doing it. But the fastest way of testing is to just send a few tokens to it. So I'm going to send some ETH to it. Why is this different? Address must be 60. Do I have more than 66 characters there? Control C. So this will, yeah, sounds like this method does not work. And that is problematic, literally speaking, but sounds like here it works. Or Agentex has got its own issues. So let's confirm. That is how much they have of it. I didn't even check my balance. So just a moment, I go back. I had 0.04, so I can send 0.01 and hit transfer, proceed. Let's see what happens. So it has transferred some funds to it. Let's see if the funds reached our account. I'm not sure why I'm unable to fetch the account, but it should be a Sepoli account. Yeah, this sounds like a problem, and yeah, it is a big problem because it sort of never created the Bravos account somehow. I don't know why. Is it because we have the default account here? Let me just change this one to deployer to remove the defaultness, and I change this one to, I'll redo the same process, but in this case with a different account name because you already have Bravos. So I have another address. I will copy this one and try to see whether it was created on chain or not. Sounds like it never came through too. So I'm not sure why they are failing. I need to confirm that one and maybe get back to you in the next class. But that's how you do it. Just use an account that's not one of the accounts in your wallets here on the browser. Otherwise, you might end up losing funds over using the same. So I'm transferring from to this address. Let's see, does this address exist? Yeah, so yeah, it exists, but it says contract not deployed. So you'll need to deploy this contract, uh, of which do I really recall the method? There's a way of deploying such contracts that have not yet been deployed. You need to deploy them. You need to call the dot deploy method on them. Let's see what happens here. Clear sncast dash dash accounts dash dash help. Oh yeah, there's the command there. So sncast, yeah, we need to use the deploy command here. So we had the Bravos account, so I'm going to just say dash dash profile here. Then after that, I'm going to profile Bravos account deploy, and I believe this one will need the name of the account. But let's just write the help command and see. Yeah, the name. So sncast count deploy dash n. I want to deploy Bravos, but of course the profile here should be Bravos profile. Let's see how it goes. Validation transaction, error message, fetch actual fee. So it can be because I don't have enough transaction fee to be able to deploy the same account. Yeah, so let me remove profile and use URL here instead. And I'm going to copy the URL from this place. Yeah, a relative URL without a base. Did I do that? Okay, yeah, I did that exactly. I didn't copy my URL. So I need to copy the URL correctly. Control C, paste. Let's see whether it will succeed. Yeah, it won't deploy because I didn't send in enough ETH or enough stack. So usually you'll need like 0.02, 0.002. That's why this process can be cumbersome sometimes. So either use Agentex to deploy your accounts to your contracts to testnet, or better even use Stack Deployer to do it, because it will give you other advantages out of the box. For example, now you can interact with your contract easily. Any questions so far? I think I need to get back to my notes here. Percent. Yeah. So here I can proceed now. We have done that. The deployment steps that you can use to deploy to Sepolia testnet. I have said use Agentex Stack Deployer or use the terminal. Then configuring the development environment for Sepolia. This one, I think it's already done for you. You don't really need to configure a heavy environment for Sepolia. Just the same stuff that we did for DevNet. Verifying the deployment and interacting with the contract. Verifying, we have said you can check on you can check on the Explorer whether your contract was correctly, or you try to call it and see whether it works. Before you deploy to mainnet, you have to do thorough testing, make sure you have done enough security audits. Otherwise, you're going to deploy something that will be taken down, as many other applications have been taken down recently. Considerations and best practices for mainnet deployment. Make sure you have considered or you have optimized your gas usage, backup and recovery. So in this case, it means like you make sure you have a better environment in case somebody notices a bug. For example, you can move funds out of the contract. That's a backup and a recovery procedure, and then return them back when everything settles down. Ensure the ability to pause or upgrade the contract if necessary. So most contracts have a pause and upgradability functionality, but when you are doing an ERC20, you don't want to do an ERC20 that can be upgraded. You can do that one, not that you can't, but it's not advisable. We have deployment strategy. Make sure your deployment strategy plan the deployment strategy, including the timing and processes, notify stakeholders and users about the deployment and the potential downtime. So this one, you have to sort of prep for your dApp going live. That means if it's an ERC20, all the stakeholders included have been notified. At least they are the early birds. They'll have to get something, etc., and all those things. Yeah. Going forward, differences between testnet and mainnet. We have said in terms of real value, testnet is just like fake value. Real mainnet, it has real value. Like everything that you use on mainnet, you have to use funds. But on testnet, in terms of network stability, mainnet is more stable and secure as compared to testnets, which might have occasional disruptions here. So this is common in most chains. So you can have testnets going down, but mainnets usually they are always stable up and running. Why? They have more resources. That's why in testnet you are only given a few test funds, not a lot, so that you can only test a little and go to mainnet so that you can spend more funds they get, then they return to testnet and all those stuff. Differences between, okay, yeah, we are on visibility. Deployments on mainnet are publicly visible and immutable, so ensure accuracy and the correctness. That's another thing. Everything is visible once you hit mainnet. Make sure you have no loopholes into your contract. What about the costs incurred? The transactions on mainnet incur actual gas fees as compared to testnets. So testnets, we said you are given some faucets for doing testnets. So procedure of deploying to contracts to mainnet. First, you will need to prepare your contract correctly, compile your contract, then follow the rest of the procedures to make sure you have deployed to mainnet. Use Agentex, use Stack Deployer, or just use the terminal. Finally, we are here at QA. If you have some questions, kindly drop them here. So a recap of what we have covered today: writing custom smart contracts. So we showed you the contract, of course, we used was from the other session. Integrating smart contracts with front-end applications using Starknet JS and Starknet React, of course, and Starknet Kit. That's what's covered for the front-end. And finally, we also covered deploying contracts to Sepolia testnet and mainnet. Are there any questions? So go ahead for more reading. We had shared some tools or some resources that include Starknet by examples written by Nethermind, by Voyage, Nethermind. We had Starknet book, Cairo book, Starknet React. So search all those, or they'll be shared with you in the groups. That's our WhatsApp groups. That includes either you are on Beach in Africa or on Kiboko DAO, you will get them. So for the future sessions, so that's it for today. For the future sessions, just prep well. Prep well in writing this Starknet smart contracts. Keep coding, keep building, and remember that we'll have to explore what is unexplored. Maybe I couldn't cover everything, so that's your part to explore. Stay engaged in our communities, ask questions in them. and you'll be a happy Starknet developer. I think I'll end it here. I think I've taken 20 of your minutes. I'm sorry for that, but yeah, so that's it for today. I will invite Harriet over.
Oh, yeah, thank you. Thank you so very much for that presentation, Dalmas. It's quite educative. About the time, you don't have to mind so much. We were learning. It's quite a learning experience. I'm impressed by how we've walked through the class. So, like we've shared there, the email hello at Beach in Africa, the instructor has suggested that you share the Vercel link. Vercel link is just like after you have developed your simple app, probably a front-end interface that is interacting with a smart contract, you deploy it to Vercel. So just share with us the Vercel link, and then we will be happy to see how your app interacts with the smart contract. Just something simple, even just a simple front end that will demo how your app interacts with it. So we look forward to receiving assignments. We'll also share feedback after going through them. It's been quite educative, and yeah, we look forward to again meeting you on Wednesday, same time. Yeah, prepare so well for smart contracts is always there with the Starknets. Uh, because now, yeah, we'll be delving deeper, and you'll realize that the skills in writing smart contracts is almost required everywhere in whatever as you proceed there with the Web3 development. Yeah, so without taking much of your time, we have on board Christopher. Christopher is the head of operations at Beach in Africa. I can just invite Christopher to say something before we close tonight's session. Over to you, Christopher. All right, so I think we just end to tonight's session. You have any questions, you can ask in the WhatsApp groups of Beach in Africa, Kiboko DAO. We work in partnership. So just ask questions. We are all there. We will be able to address your concern even as you do the assignments. Thank you. We call it a day and have a good night all. Bye.
Bye.